In this video, we're going to talk about another oligopoly model. This is going to be the Bertrand model. So we've already discussed Cournot. The Cournot model is where firms simultaneously choose output that they're going to produce. And in the Bertrand model, the firms are going to simultaneously choose price. So Joseph Bertrand was a French mathematician. And he wrote a paper, essentially a criticism of Cournot's paper, about 50 years after Cournot published it. And the biggest contribution of Bertrand is really to point out how different the outcome is when firms choose prices rather than when firms choose quantities. So we're going to be thinking about a model that's very similar to the Cournot model. The setup will be similar. So we're going to have two firms. Those firms are going to be selling identical goods. We're going to have a constant marginal cost, C. So marginal cost is going to be C, just like with the Cournot model. Our firms are going to choose their prices simultaneously. And then we need a market demand curve. So market demand is going to be P equals A minus BQ. Now, that's what the market demand was with Cournot. In the Cournot model, firms are choosing quantities, and when firms choose quantities, it's easiest to think about working with the inverse demand curve. But now we're going to switch to where firms choose prices. And in that case, it's easier to think about the demand curve. We want Q over here rather than P. So if firms are choosing Q, we like that to be the independent variable, what gets chosen, and then P is the result. But if firms are choosing P, we want to get P over on the other side. So what we're going to do is simply rewrite it like this. Q equals A minus B over P. Now that's the demand curve rather than the inverse demand curve. And if you wanted to keep it completely consistent with this, we could let A equal A, capital A divided by capital B, and B equals 1 over B. So if you were to substitute, if you were to invert this, then you're going to get a demand curve that's got capital A and capital B in here. But we want to keep things nice and simple, so we're going to make some substitutions there for little a and little b. So now, when firms have identical goods and they're choosing prices, the consumers in the market are going to be buying, because the goods are identical, the consumers will just buy from whichever firm has the cheapest price. So let's think about firm 1 and firm 2. If firm 1 has a lower price than firm 2, then the customers are all going to buy from firm 1. Firm 2, the firm with the higher price, will sell nothing. If they have equal prices, if P1 and P2 are equal, then the firms are going to split the market. Okay, so half the consumers buy from firm 1, half the consumers buy from firm 2. And then finally, if firm 2 has a lower price than firm 1, then firm 2 is going to sell to all the customers and firm 1 sells nothing. So we can write this out. Let's write it out in terms of demand for firm 2's output. So demand for output from firm 2. Let's say firm 2's output. Here's what it's going to look like. It's going to be 0. Q2 would be equal to 0 if P2 is greater than P1. So firm 2 has a higher price than firm 1. All the customers buy from firm 1 and firm 2 sells nothing. Let's think about if they have the same price, then quantity demanded from firm 2, the demand curve is going to be the market demand curve divided by 2. It's going to be A minus B P2 divided by 2. They are going to sell half of the market quantity, and that is going to be true if P2 and P1 are equal to each other. And then finally, if P2 has the lower price, the quantity that it's going to sell is going to be the full market quantity, A minus B times P, if P2 is less than P1. Now, what this means is that the demand curve is not continuous. This introduces a discontinuity into the demand curve. We can actually draw what the demand curve looks like in this case. So what we're going to do is put P2 up here, and we're going to put Q2 down here. So we're going to be drawing the inverse demand curve. Now, firm 1 is going to choose a price, and we'll just put it up here, whatever firm 1, the price is that firm 1 chooses, because what firm 2's demand curve looks like depends upon firm 1's choice of P1. Now, if this is what firm 1 has chosen and firm 2 chooses a price higher than that, they're going to sell nothing. So the demand curve that they face would be this vertical axis above P1. Let's think about if price is equal to P1. Actually, let's think about price being a little bit lower than P1. In that case, the firm 2 is going to be the only firm in the market, and the more firm 2's price is below firm 1's, the more firm 2 is going to sell. So the demand curve is going to be just the rest of the demand curve. This would be the market demand curve at any price below P1. So if firm 2 sets a price down here, they're going to sell a quantity out here. But if firm 2 has a price that's exactly equal to P1, they split the market. So their quantity demanded is going to be right there in between the full market quantity, and so this quantity right there would be that. It would be A minus BP2 over 2. Let's put a little dotted line right there. So this situation, that's the quantity demanded that they would face if their price, P2, is greater than P1. Right here, this dotted line with the dot right in the middle represents a situation that would exist if P2 and P1 were equal to each other. And this is the demand curve that firm 2 would face if P2 is less than P1. So you get this somewhat unusually shaped demand curve. Now, because the demand curve is discontinuous, the profit function is also going to be discontinuous. Let's just write out what profit would be. So if we think about profit, we've got our quantities here. We just need to multiply that by the difference between the firm's price and its marginal cost. So if firm 2's price is greater than firm 1's, then firm 2 is going to sell nothing. Their profit would be equal to 0. So that's if P2 is greater than P1. The profit for firm 2 would be equal to that difference between their price and their cost multiplied by their quantity. That's going to be multiplied by A minus B P2 over 2. That's going to be true if P1 is equal to P2. The two have the same price. And then the profit for firm 2 would be this difference between the price and their cost. But now we're thinking about the situation where P2 is less than P1. So they're going to sell the full quantity, which would be A minus BP. So you get this discontinuous profit function. Now what we're interested in is we need to figure out each firm's best response function, right? That's what we're after. It's going to be useful to compare that to the monopoly price. So if we pretended we had this situation with this market demand curve, and we thought about what the monopoly price would be, You could use this inverse demand. You could invert that to get the inverse demand curve. You could find the marginal revenue curve. You could set marginal revenue equal to marginal cost and solve for Q and then plug that back in to get P. If you do that, what you're going to get is that the monopoly price is going to be A plus BC over 2B. So if you want to work through that, that's easy to do. But that's what you're going to get, okay? And we're going to use that to kind of think about coming up with each firm's best response to what the other firm is going to do. So there are a few different possibilities here. Let's think about one possibility, and that is that let's suppose, so we're going to take the perspective of firm 2. So firm 2's got to figure out what firm 1 is going to do, all of the possible things firm 1 could do, and then what firm 2's best response is to that. So one possibility is that firm 1 could choose a really high price. So maybe firm 1 chooses a price higher than that one. Price higher than the monopoly price. Now, if you think about it, there's really no reason for firm 1 to do that, but we need to consider all of the possibilities. In that case, firm 2 should just choose the monopoly price because that would be lower than firm 1's. They would get the full market and they would have a monopoly. Okay, now we know firm 1 is not going to want to do that, but that tells us set P2 equal to the monopoly price. Okay. So there's another possibility, and that is that maybe firm 1 could choose a price below marginal cost. So maybe firm 1 chooses a price below C. Now again, there's not going to be any reason firm 1 wouldn't do that, but we need to consider the possibility. In that case, it's better for firm 2 to set a price above P1. So set P2 above P1. Now, you're not going to sell anything, right? Firm 1's going to capture the entire market, but they're going to be losing money because they've got a price below their cost. But it would be better, you don't want to match firm 1's price because now you're also losing money. So in that case, set a price above P1, you sell nothing, but that's better than losing money. And then let's think about the more likely case, and that is that maybe firm 1 sets a price in between the marginal cost and the monopoly price. Price between, let's say, greater than or equal to C and less than or equal to PM. So let's think about what that would look like. So in that case, we can draw a picture of what profit's going to look like for firm 2. So I'm going to put P2 down here, and I'm going to put profit for firm 2 up on our vertical axis. I'm going to put the marginal cost right here, and I'm going to put firm 1's price right here. So the monopoly price would be somewhere out in here. So firm 1 has chosen its price. So now let's think about what profit is going to look like based on the price that firm 2 chooses. Okay, so let's think about what would happen if, I'm going to put a little dot right up here, and that's going to represent the full amount of profit that's earned in the market, okay? But if firm 2 sets a price equal to P1, it's going to split the market and get half of that amount. So the profit for firm 2 would be that dot if P2 is equal to P1. Now, if there were only one firm, that one firm would earn all of this profit, and then we know that as price gets closer and closer to their cost of production, profit goes to zero, right? So the profit is going to be declining like that. Okay, and I'm going to put a little dashed line here just to kind of link everything up so it's easy to see what's what. Emphasize that point right there. Okay, so if price for firm 2 is greater than P1, they're going to get zero profit, right? That would be the rest of the thing. If price is equal to P1, if firm 2 sets a price equal to P1, they get half of the profit. But now notice the incentive that this creates. If firm 2 were to just undercut firm 1's price, notice what happens to their profit. It jumps to almost double, right? So there's always going to be this incentive for firm 2 to undercut firm 1's price. Now this whole setup is symmetrical, so we could do the exact same type of picture for firm 1, and what we would see is that firm 1 is always going to have an incentive to undercut firm 2's price. Let's think about the fourth possibility, and that is maybe firm 1 sets price equal to marginal cost. P1 equal to marginal cost. Well, in that case, firm 2 shouldn't undercut, because if they undercut, now their price is below their cost of production and they earn a negative profit. If they set firm P2 equal to P1, which is equal to C, they split the market, profit will be equal to zero, but profit's not negative. And remember, that's economic profit, right? So all of their costs are covered, including the opportunity cost of their time and all of that. So what we would say, a better way to say it would be set P2 greater than or equal to P1. They're going to earn zero profit if they set price equal to P1, and they're going to earn zero profit if they were to set price P2 greater than P1. So that's the correct way to say it. Turns out that the Nash equilibrium of the game, a situation where nobody has an incentive to change their strategy given the strategy chosen by the other firm, is for both prices P1 and P2 to be equal to marginal cost. There's always an incentive. If price were ever greater than the cost of production, there's always an incentive for firms to undercut. And remember, we're thinking about this Nash equilibrium in the sense that the decision makers of the firms can each play this game out in their mind. That we don't need some iterative process where they set a price and it gets undercut and then undercut again. We don't need to go through that. This is the only situation where nobody has an incentive to change their strategy given the strategy chosen by the other player. So that's the basic outcome of the Bertrand model. It's the exact same as perfect competition. So if you were solving for, say, the equilibrium price with a Bertrand situation, then you just set price equal to marginal cost and solve for Q. That's your total market quantity. Each firm would have half of that. And then you could figure out everything else. It'd be easy. Your profit's going to be equal to zero. So solving a Bertrand problem is not hard, as long as you know that the outcome, the Nash equilibrium, is where the price in the market for both firms ends up being equal to marginal cost. Now, there are some criticisms of the Bertrand model. This is very different from the Cournot outcome, right? Where price obviously was greater than marginal cost and the firms made profit. There have been two main criticisms that have kind of emerged in the literature that change this basic Bertrand outcome. The first one is that for the undercutting to work, the other firm has to have the capacity to sell to all of the new customers it's going to get when it undercuts the other firm's price. If the firm doesn't have the capacity to sell all of those units of output, then we're not going to see this outcome, and we're going to talk about that here in a second. So capacity constraints, that can be a thing that changes price being driven to marginal cost. The other thing that can change that is that what we've assumed in this model is that the goods are identical. If the goods are not identical, then what that means is one firm can have a higher price than another firm and still not lose all of its customers. And so if the products are not identical, if the products are differentiated, then we don't get this extreme switching where undercutting causes you to gain all of the market. So what I need to do is I need to clear this off, and then we're going to talk about each one of those situations. Let's consider a situation where we've got two ski resorts, and let's suppose that each resort is located on the opposite side of a mountain. Let's suppose that consumers treat the two resorts as perfect substitutes for each other. The goods are identical, and so that means that the consumers are going to go to whichever resort has the lowest price for their lift tickets. Let's suppose that each firm has the capacity for 1,800 skiers. So they have facilities built to accommodate 1,800 skiers, let's say a day. No more. Let's make our market demand equal to Q equals 6,000 minus 60p. So there's a nice simple market demand curve. And let's make marginal cost equal to $10 per skier. Now let's start by thinking about the basic Bertrand model. The basic Bertrand model tells us that price would be driven down to $10. But in this particular situation, we've got this capacity constraint for each firm. And so we know that that price equal to $10 cannot possibly be a Nash equilibrium, because if we plugged in a price of $10 into this demand curve, it would be 6,000 minus 600, which is 5,400 skiers, and the firms together do not have the capacity to sell to that many customers. They've got the capacity, two firms, each can sell to 1,800 customers. That's 3,600 customers they could sell to. So this introduction of a capacity constraint means that the outcome of this game is not going to be the price equal to $10. So what we need to do is we need to think our way through and think about what the outcome is going to be. Let's think about a situation where, let's think about it from a single firm's perspective. What is the problem that's introduced for a single firm by this capacity constraint? So let's think about a price in the neighborhood of $10, in the neighborhood of marginal cost. So you can think about a price of $11. And I realize total quantity demanded in the market is going to be bigger than the capacity, but bear with me. If we think about a price in the neighborhood of $11, and you think about the situation that puts a firm in, for them to undercut, they're already going to be at capacity. So when they undercut, they have no ability to sell to all the customers that they would get from the other side of the mountain who are now going to want to buy from them. So they don't have the ability to meet the demand if they charge a lower price. You might ask this question, well, why doesn't each resort expand their capacity to satisfy the entire market? So we just saw that at a price of $10, the total quantity demanded in the market would be 5,400. So why doesn't each resort create enough capacity to serve 5,400 customers? And the answer to that would be that, let's suppose they split the market. Well, let's suppose that they are at capacity and they are splitting the market. Actually, let's think about a price a little bit higher than that, where one firm has a little bit higher price than the other firm and is serving the entire market. Well, if the firm that doesn't have any demand at that point wants to undercut the second firm, it can, and because it would have a capacity for 5,400 customers, it could handle the demand. But here's what's going to happen. They undercut, and the outcome would be that price gets driven to marginal cost for both firms. And in the Nash equilibrium, each firm would get half of the market, which means they would have half of 5,400. So they would have a whole bunch of unused capacity, and building that capacity is costly. So there would never be a time when a firm would use all of that capacity. It has to have it to make the threat credible that it's going to undercut the other price, but the undercutting would lead to an equality of price and a splitting of markets. So there's not going to be a reason that they would expand their capacity to 5,400. Let's think about kind of what happens now that we've introduced this capacity constraint. So essentially, this kind of changes the game into a two-stage game, where in the first stage, each firm chooses its capacity, and then in the second stage, each firm chooses its price. So the nature of the game has changed a little bit, but it turns out that the outcome of the game with these capacity constraints ends up being very, very similar. In fact, in this problem, it will be identical to the Cournot outcome. So introducing the capacity constraint changes the outcome of the game dramatically. Let's work our way through it. Now, here's what we need to do. We need to introduce an assumption in order to simplify the problem a little bit. And the assumption that we're going to introduce, so we need to think about who a firm is going to sell to if it faces excess demand. So let's think about something that you've seen someplace else where you have this situation. So if you think about the situation where there's a price ceiling in a market. So remember, a price ceiling is a situation where the government sets price below the equilibrium. And the problem that creates in the market is that at that price below equilibrium, quantity demanded is going to be higher than quantity supplied. You're going to have a shortage of the good. And then when you have a shortage of the good, price no longer rations the good. And some other rationing mechanism has to emerge. This is the problem with price floors and ceilings, is that they create inefficiencies in the market. And so the other rationing mechanisms, anytime you have a shortage, are going to be things like a line or favoritism or discrimination, things like that. What we need to do, because we're going to have a situation in this problem where there's excess demand, we need to have some assumption about who's going to buy and who's not going to buy. So if a firm faces excess demand, which customers is that firm going to sell to? So we're going to make an assumption that's known as the efficient rationing assumption. Efficient rationing assumption. All this says is that if quantity demanded is greater than quantity supplied, the firms will sell to the consumers with the highest willingness to pay. Firms sell to the consumers with the highest willingness to pay. Now, the logical question is, well, how would they do that? How would they identify the customers that have the highest willingness to pay? Because the customers would have zero incentive to reveal their willingness to pay. They would have an incentive to exaggerate their willingness to pay. So this is not just a simple assumption. In fact, this is sometimes an assumption that's made by people who want to claim that price ceilings are a good policy. They're not a good policy. They're inefficient unless you make this efficient rationing assumption. But the reality of it is that in the real world, that's not how things work. But to work through this problem, we're going to make the assumption. Now, you might ask, well, okay, so why in this problem do we need to make it? It's because we need to figure out what a firm's demand curve looks like after the other firm sells to a chunk of the market. And so you'll see, I think, when we get there, how this helps us. It helps us a lot. It should be highest. So we're going to make this efficient rationing assumption, even though personally I find this assumption to be highly unlikely. It does not happen in the real world, but we're not in the real world. We're working through a problem. Let's consider a price of $40. Consider price equal to $40. And we're going to think about both of them having a price of $40. So if P1 equals P2 equals 40. Then total quantity in the market is 3,600. So remember, the capacity for each firm is 1,800. So that's why we're starting with this price of 40. Because that would result in each firm selling exactly the number of tickets that it has capacity for. So it's equal to the total capacity of both resorts. If firm 1 sells to 1,800 customers, so if firm 1 sells to 1,800 customers, what does demand from firm 2 look like? What does demand for firm 2 look like? If you've studied monopolistic competition, then you know that with that situation, we talk about a residual demand curve. A residual demand curve is the demand curve that a firm faces given what another firm is selling in the market. So some customers buy from firm 1, some customers buy from firm 2. Given that 1,800 customers buy from firm 1, what does the residual demand curve from firm 2 look like? And this is where we're going to use this efficient rationing assumption. So our market demand looks like this. It is equal to Q equals 6,000 minus 60p. So what if 1,800 customers buy from firm 1? Well, that would leave the rest for firm 2, right? So firm 2 would face the residual, what's left over after firm 1 is sold to 1,800 customers. And this efficient rationing assumption allows us to figure out, well, which 1,800 consumers would it be that firm 1 sold to? Well, we're going to pretend like it's the customers with the highest willingness to pay. And what that allows us to do is say, okay, the demand curve that firm 2 would now face would be 6,000 minus those 1,800 minus the 60p. So we just subtract off 1,800 of the customers, the ones with the highest willingness to pay. So then that leaves our demand curve as 4,200 minus 60p. That would be the residual demand curve that firm 2 faces if firm 1 sells to 1,800 customers. Now we want to invert that. We need to set marginal revenue equal to marginal cost. So we need this in terms of P. If you invert it, nice simple algebra, but what you're going to get is P equals 70 minus Q over 60. That's the inverse demand curve that firm 2 would face. We want to set marginal revenue equal to marginal cost, so remember your marginal revenue curve always has the same intercept as your inverse demand curve and twice the slope, so it would be Q over 30. So there's our marginal revenue curve for firm 2. Now we need to think about, remember firm 2 has a capacity constraint, so we need to think about what this looks like. I'm going to draw 2 pictures. So if we were to draw this demand curve, it would be right up here, intercept of 70. It's going to come down like that. There's our demand curve. We've got a marginal cost curve here at 10. So it comes across here. There's marginal cost. We've got our marginal revenue curve that looks like that. Same intercept and twice the slope. But we don't have capacity in here. Okay, so once you introduce a capacity constraint, the firm can't sell to all of these customers out here. So I'm going to change this a little bit. I'm going to add the capacity. And so it's going to be some quantity beyond which the firm is not capable of selling those units. So I'm going to just put it right here. There's 1,800. That's our capacity, right? We can represent it as a vertical line that you can't cross. These quantities out here are not going to get sold. So now if we think about our intercept of 70 and down here's 10, our demand curve is going to end up looking something like that. Our marginal revenue curve comes down, looks something like this. And we've got our marginal cost that comes across like that. There's our demand. Marginal revenue. So things change, right? It doesn't, this portion out here, actually, this intersection is beyond the capacity of the firm. It turns out that now the firm's marginal revenue and marginal cost, because that marginal revenue curve gets truncated right there at a quantity of 1,800, it turns out that marginal revenue equals marginal cost at quantity equal to 1,800. And then charging a price equal to $40 ends up being the best option for firm 2 to choose. We could draw a similar picture for firm 1 if we wanted. Remember, the problem is symmetrical. So the Nash equilibrium in this game with capacity constraints. Equilibrium is each firm chooses a capacity equal to 1,800. I'm going to say each firm. And then each firm charges a price equal to $40. And they sell a total quantity exactly equal to the sum of their 2 capacities. It's easy to show that a capacity of 1,800 is the best choice for each firm, given that the other firm has chosen that. We don't need to go through that here. You can trust me on that, or you can go look, find information in the textbook or for a Bertrand model with capacity constraints, and you'll see the argument that demonstrates why that's the best option. This is the same outcome as Cournot. If you set this problem up as a Cournot duopoly, you'll get that outcome. So if you have a Bertrand model but each firm has capacity constraints, well, then that dramatically changes the outcome. You're not going to get price driven to marginal cost anymore. We need to think about differentiated goods now. What happens if we change that assumption that the goods are identical? I'm going to clear this off and then we'll talk about that. Let's think about now changing the model to allow for the firms to have differentiated goods. And you can think about this. This would be true if you had, say, a town that had 2 pizza restaurants in it. And so the 2 businesses are, the pizzas are, I mean, a pizza is a pizza, but it's not every pizza place has a different style or a little bit different pizzas. So, and it could be the decor in the restaurant. It could be that the people who, the wait staff is nicer. It could be a variety of things that might make you prefer one over the other. And there can be a situation where there are big differences. There could be situations where the differences aren't that big. They're minor. And we'll talk about how that shows up in this model. What this means, as soon as you introduce differentiated goods into the situation, what that means is that a firm can have a little bit higher price or maybe even a lot higher price than another firm and still not lose all of its customers, because some customers are going to prefer the good from that firm. So if you start with a situation where 2 firms have identical prices and one firm undercuts the other, well, it's not going to now capture the entire market, because there are going to be some customers that still prefer that other firm's good enough to pay a little bit higher price. Or again, if they prefer it a lot more, they may be willing to pay a lot higher price. What we can do is we can use that spatial model that we've talked about in another video, Hotelling's spatial model, which I find to be a fairly interesting model. We can use that to understand how to incorporate that into our Bertrand model here. So what we're going to do is we're going to consider a line of 1 mile length, right? So we've got a line 1 mile long. We'll think about that as being our town. Our customers are going to be uniformly distributed along that line. And we're going to be thinking about 2 firms. Now, these firms are not going to be owned by the same owner. These are going to be 2 rival firms. In our original discussion of the spatial model, we were thinking about it really as we set it up as a situation where you've got a firm that's setting up locations. We also know that you can generalize that because it doesn't have to be location. It can be any attribute of a product. And the same is going to be true here. But now, in this case, we're going to be thinking about these firms as being competitors with each other. We're going to have one firm right down here at x equals 0. Remember, x is a position along this 1 mile line. It's going to be an address. So we're going to put firm 1 down here. And up here at x equal to 1, we're going to put firm 2. So we've got our 2 firms located, one at one end and one at the other. We're going to have a constant marginal cost equal to C as usual. And then a customer's location along this line is going to be given by X, which is their address. So if X equals 1/2, they are 1/2 way along this line. They would be a 1/2 mile from firm 1 and a 1/2 mile from firm 2. Now, customers differ in their location. And remember, we can think about this not just in terms of location, but in terms of a pizza at this restaurant and a pizza at another restaurant, and how much you like the pizzas from the 2 restaurants. You may have a location down here where you prefer the pizza from firm 2 much more than you do from firm 1. Okay? So we can think about your location here as being related to how close the good is to the exact pizza that you like. Okay, so doesn't have to be distance, although it's easiest to think about it in terms of distance. So consumers differ in their location, but they're all going to have the same reservation price. So remember, in the spatial model, we call that reservation price V, standing for the value that they place on the good. All the consumers place the same value on the good. It's just that they differ in terms of their location. Okay. And we're also going to simplify by making it the case where at most each consumer buys 1 unit. So as long as the price that the firm charges plus any travel cost or disutility costs that they incur, as long as that price is below the value that they place on it, they buy the good. Now, if a customer buys a good that isn't their most preferred, they incur a cost. In the same way that if they are right here and they travel to this store to buy it, they're going to incur a travel cost. So we can think about it as travel cost or some penalty, disutility penalty. But let's say consumer X purchases a good. Consumer X purchases a good that's not their most preferred. The cost is going to be, cost is TX if they buy from firm 1, if good 1 is the one that they purchase. And it's going to be T times 1 minus X if they buy good 2. From down here. So let's suppose the customer is at 1/4. So they are 1/4 of a mile from firm 1 and 3/4 of a mile from firm 2. That's where the 3/4 comes from. Okay. Now, which firm they buy from, of course, depends on the price that firm 1 charges and the price that firm 2 charges. Okay. So they may be down here on this end and still buy from this firm if firm 1 charges a high enough price relative to firm 2. So the location of the customer, their address, doesn't tell you what they buy aside from the price. We have to consider that as well. Now, what we want to do is we want to say, what's the price that the customer would pay if they buy from firm 1? So in the case of buying from firm 1, customer's price would be equal to P plus TX. Their consumer surplus would be equal to V minus, I'm going to say P1 minus TX. So that's the consumer surplus that customer X would get from buying from firm 1. Here's the value they place on it minus the price minus the utility penalty they pay because it's not the exact good that they want. Let's skip this step and let's say if they buy from firm 2, let's just talk about what their consumer surplus would be. It's going to be V minus P2 minus this cost, T times 1 minus X. So there's the consumer surplus the customer X would get if they buy from firm 2. And again, the firms compete with each other by choosing P1 and P2. And they're going to choose simultaneously. To keep it simple, we're going to assume that V is big enough that every customer in the market is served. Okay. Now, what we want to do is we want to consider the marginal consumer, the marginal Yeah, let's say marginal consumer. The marginal consumer would be the consumer based on the prices charged by the two firms. The marginal consumer would be the consumer that's just indifferent between buying from firm 1 and buying from firm 2. So this marginal consumer is indifferent between buying from the two firms. Buying, let's say, from firm 1 and from firm 2. We're going to call them XM. That's our marginal consumer. And we can put them anywhere on here, right? They're just going to be at some location, XM. Now, because they're indifferent, we know that they get the same consumer surplus from firm 1 as they would get from buying from firm 2. So this and this are equal to each other. So the consumer surplus they get from buying from firm 1 minus TX, I'm going to put the M there with our X because this is our marginal consumer now. That's equal to the consumer surplus they would get if they bought from firm 2. So that allows us to say that those two things are equal. You can solve for XM if we grouped things and did a little bit of algebra, which is not hard algebra. You could solve for XM, and here's what you're going to get. You're going to get P2 minus P1 plus T over 2T. There's what you're going to get if you solve that for the address of the marginal consumer. What this says is, okay, this tells us given firm 1's price and firm 2's price and the travel cost, the magnitude of the travel cost, this tells us the percentage of customers that buy from firm 1 and the percentage of customers that buy from firm 2. So if we solved it, we plugged things in, and XM ended up being right here, then that means this portion of the consumers in the market are going to be buying this good, and this portion of the consumers in the market are going to be buying from firm 2. XM is just a fraction of consumers. Now, if we have N consumers, right, that's how many consumers we assumed there were. With N consumers, the demand, let's say, facing firm 1. I'm going to write it this way. Demand for firm 1, which of course depends on the price that firm 1 chooses and the price that firm 2 chooses. That's going to be this number. That's going to be this portion. Remember, this is just a fraction of N. So it's going to be P2 minus P1 plus T over 2T multiplied by N. For firm 2, demand for firm 2, which of course is a function of the prices chosen by the two firms, this is symmetrical, so it's going to be P1 minus P2 plus T over 2T times N. And this makes sense in this, if you think about these signs here. So let's think about demand for firm 1. Notice that if you increase firm 1's price because it shows up with a negative sign, that means quantity demanded from firm 1 goes down. Likewise, these two goods are substitutes because if we increase the price that firm 2 charges, because it shows up in the numerator here with a positive sign, it increases demand from firm 1. So we have these effects. The same thing happens here. This is demand for firm 2, and if you increase P2, this goes down. if you increase P1, the other firm's price, this goes up. So these demand curves make sense to us. It's also the case that these demand curves are continuous, right? Remember with the Bertrand model, just the basic Bertrand model, the demand curves were discontinuous and kind of unusual. These are continuous demand curves in both prices. We can also write profit for each firm. So profit is easy once you've got the demand curve. This is a quantity. So the profit for firm 1, which of course depends on the price firm 1 chooses and the price firm 2 chooses, is equal to the difference between P1 and cost multiplied by this quantity, multiplied by P2 minus P1 plus T over 2T multiplied by N. These are running together here, so I apologize for that. And then profit for firm 2, which is a function of P1 and P2, is equal to P2 minus cost of production. This is the profit they make per unit times the number of units they sell, which is going to be P1 minus P2 plus T over 2T multiplied by N. Now, what we're interested in is we need to know how firm 1's profit is affected by changes in the price of firm 2's good. And likewise, we need to know how firm 2's profit is affected by changes in P1. So there's a straightforward way that you can do that. You can take the derivative of this profit function with respect to P2, and you can take the derivative of this profit function with respect to P1. We're not going to worry about that. Another thing that you can do is the thing that doesn't require any calculus, and that's simply that you can take the demand curve. This is a demand curve. You can invert it. You could solve this thing for P1. Okay, that would give you the inverse demand curve. Once you've got the inverse demand curve, you can get the marginal revenue curve. And once you have the marginal revenue curve, you can set it equal to C, which is the marginal cost. And doing that is going to give you the same equation that you get out of this. Okay? The first equal marginal principle. I'm not going to do that. We've done that several times. The algebra is not hard, but to save time, I'm going to show you what each firm's best response function is. Once you get that done, here's what you're going to get. The best response function for firm 1, the price that they should choose, ends up looking like this. It's P2 plus C plus T divided by 2. That's firm 1's best response function. Firm 2's best response function is going to be P1 plus C plus T divided by 2. They're symmetrical, obviously. And each firm's optimal choice of price depends upon the other firm's price that it chooses. Now, here's the interesting thing about this. These things are upward sloping. Notice that there's a positive relationship between P1 and P2 here, and obviously a positive relationship between P1 and P2 and that one. If we graph these response functions, we're going to graph them in this space where we've got P1 down here and we've got P2 up here, right? That's the decision space for the two firms. Then firm 2's, this is the easiest one to graph. Firm 2's response function looks like this, and firm 1's best response function looks like that. So this is for firm 2, for firm 1. And the intersection of those two best response functions is the only place where each firm is making the best response to what the other firm is choosing. It would be the Nash equilibrium, P1 star, P2 star would be given by that intersection. So you can take these two equations, and two unknowns, you can plug P2, which is this, into there, solve it, and here's what you're going to get. You're going to get that the optimal price, P1 star, is going to be equal to P2 star. It's going to be equal to C plus T. It's equal to the marginal cost plus the disutility cost or the travel cost. So each firm charges a price equal to the unit production cost plus an amount T, which is that utility cost per unit of distance that the consumer incurs because they're buying a good that is some distance from their most preferred good. Now let's talk about T in particular. The bigger T is, the bigger the disutility cost. This represents the strength of preferences for the consumer. So the bigger T is, the stronger consumer preferences are, and then the higher the price is going to be, because consumers care a lot. They incur a lot of disutility because they have to buy a good that's a ways from the good that they would really prefer. One question you might have had when we set this model up is, why did we put firm 1 here at this end, at this address, and firm 2 at the other end? How do we know that firm 1 doesn't want to be here and firm 2 there? And let me just say that that's beyond, the level of complexity of explaining that is beyond what we want to do here. You can find that done other places, but we're going to leave it at this. Let's talk about what happens if costs change. We can allow the cost for firm 1 to be different from the cost for firm 2. So I'm going to clear this off and then we'll take a quick look at that. Let's take a look at the response functions from the Cournot model and compare them to what we just came up with for the Bertrand model. So if we think about the Cournot model, put it here, and then we'll put Bertrand here. So this is going to be Cournot, Bertrand. We're talking about Bertrand with differentiated goods here. So we've got, with the Cournot model, the space, that the decision space was how much output firm 1 produces and how much output firm 2 produces. With the Bertrand model, it's prices, so P1 and P2. And so what we got with the Cournot model is the response function for firm 2 looked like this, and for firm 1 it looked like that. So this was firm 2, and this one firm 1. And you have this intersection that gives you the quantity, the Nash equilibrium, the quantity that firm 1 produces and the quantity that firm 2 produces. And then what we just came up with was something that looks a little bit different. And that is that we had firm 2's response function upward sloping like that, and firm 1's response function upward sloping like that. And there's your intersection that gives you the Nash equilibrium price for firm 1 and the Nash equilibrium price for firm 2. Now the slopes there are different, obviously. The response functions have a negative slope in the case of the Cournot model and a positive slope in the case of the Bertrand model. And we can think about what happens if the marginal cost of production were to change for the two firms. Let's keep it nice and simple and say, let's consider an increase in C2. Okay, so let's consider an increase in firm 2's cost of production. Now, what we saw with the Cournot model was that that would shift firm 2's response function. And the way it would shift it is that firm 2's response function would shift down. I don't know if that difference in color shows up. So let's say with Cournot, what happens is that firm 2 now would produce less and firm 1 produces more. Firm 2 less, firm 1 more. So essentially what happens is that firm 1 takes market share from firm 2. The competition is more intense. Competition's more intense. Now let's think about what happens if we have an increase in marginal cost for firm 2 with the Bertrand model. So Bertrand, with differentiated goods, if you go back and you look at the functions for those response functions, functional forms for them, what you'll see is that the intercept of firm 2's response function is going to increase, which means that firm 2's best response function is going to shift up like this. So we get a new intersection out here. And so what happens is that firm 2 charges a higher price. Right? So firm 2's price is going to go up, and firm 1 also charges a higher price. In other words, the competition now is less intense. Both of them are, it's not the case that somebody's trying to steal a big chunk of market share. It's that both of them realize that it's become more costly for firm 2 to produce the good. They're going to charge a higher price, and firm 1 takes advantage of that and says, oh, well, if you're charging a higher price, I'll charge a higher price as well. So you have competition less intense. And we've got a name for that. What we would say that with this Bertrand model, we would describe the strategies as strategic complements. Strategic complements. In terms of the Cournot, this intensification of the competition after the increase in firm 2's marginal cost, we would describe these as strategic substitutes. What this points out is really that the choice of how we choose to model a particular industry is important. So if you've got a situation where firms have to pick production schedules ahead of time, so this could be something where you have large pieces of machinery, aircraft, or machinery used in automobile manufacturing, or even if you had, say, an orchard or a vineyard where you have to plant a certain number of plants ahead of time, and you have to wait until those plants become mature before you start being able to harvest from them. In all of those cases, the firms have to choose the quantities early. And in that sense, we should probably model it as a Cournot situation where firms are competing with each other in terms of quantities that they choose. On the other hand, if quantities can be adjusted very rapidly, so if we're talking about service industries, then it's going to be usually more natural to think about firms competing in terms of price. And that Bertrand really pointed out that that's very important, that whether a firm competes in terms of, firms compete in terms of quantities or whether they compete in terms of prices can have huge impacts on the outcome of the model. So I hope that gives you a good idea of what the Bertrand model looks like, both when we're thinking about capacity constraints and when we're talking about differentiated goods, and I'll see you in another video.